Now we are very familiar with logic gate circuit. So we are going through few examples without any hassles. Now you should be able to understand truth table, Boolean expression, drawing logic gates, everything. Now you see this gate, how many inputs, right? We are not counting with these lines, right? Here 1, 2, 3 lines, but you have to see the variables, right? Only two different signals. Now if you put A here, then we need to consider as one signal. Then the truth table is for 0 and 1. Here A and B, two different. So then 2 to the power 2, there will be 4 combinations, right? Now you can easily write Boolean expression for this logic gate. Now you are very familiar, right? You should be able to write the Boolean expression. Just assume and see, right? Now we can see here A, B, this is the AND gate, this is the NOT gate. How we can fill the truth table? So we can write like this, then this way it is very convenient, you won't miss out anything. You can assign a dry letter for this output, and you can assign a dry letter for this output, and we can see the final output. So A, B we are writing for D. Then you see here A and B, D. Only when A and B 1, you get 1. So you don't need to see all combination. Definitely we know, no? So then all you can just fill with zeros. Here only when B is 0, you get 1 here. So first of all, you need to write all possible combination 0 0, because here only we are feeding signal, no? 0 0, 0 1, 1 0, 1 1, 0 to 3, no? So you need to fill this. Then we can see here the B 0, you get E1, 1 means 0, like you are feeling this. Then we are not worried about these two now. Now we are comparing only these two. This is the OR gate, no? So whenever you get any of these 1, you get 1 here. Then you can fill this, right? Now see the Boolean expression. A and B or not B, right? This is the Boolean expression. These are just additional things, right? Again, now you can read it and understand this. That is very important. X is 1 only if A is equal 1 and B is equal 1, or not B is equal 1. Very simple. Now you should be able to understand this, right? Even though it is the lengthy the line. Now see here, this is the OR gate. So to this to become 1, either this or this need to become 1, no? So this to become 1, A and B need to be 1. That is one condition. Otherwise we don't care whatever the condition here. This to become 1, B not, right? Not B should be equal to 1. Therefore now you should be able to read it and understand. Now see this. How many inputs? Inputs 1, 2, 3, 4. Because definitely for one gate we are having 2 inputs, no? But see the how many different kind of signals? 3. Then 2 to the power 3, 8 combination. 8 combination means 0 to 7. So you should be able to write all this. Now you are very familiar with binary, right? 0, here the value 1, here value 2, this value 3, 4, 5, 6, 7. You should be able to write it in binary. After that, simple, right? We are separately writing E and we are separately writing F. Then we compare this for this output. That's all. Right. Now see here, X is equal A and B, O, A and not C. Here definitely there will be an AND gate. A and B, no? Then O, X is the output starting from here. A and B, O, A and not C. A and B signal getting AND combination, then A and not C. So this is actually the O gate. So one branch is this, because they are clearly bracketed here, no? The one branch is the other side. So then we need to start from the O gate and we need to write one branch and the other branch. Very simple, no? A and B, A and not C. We'll see here. Right. Now here this is the AND gate. A and B. Right, correct. A and B is written. Then A and not C. Right. A other side branch is A and not C, no? So here you don't need to put A separately. From here itself you can link, no? A and you input C, not gate, then you get not C. Right. Now both side expressions we have implement the circuit, no? Now O gate. Put O here. It's very simple, no? With the O itself, you know this is one branch, this is one branch. Otherwise, if you are starting from one side, you can start from here, then you can put the other branch, and then you can see whether it is an AND gate or O gate, you can implement here. Therefore, now you should get very familiar, right? Even the Boolean expression to logic gate to Boolean expression, truth table, everything. Right. Now here, how many inputs? A, B, C. 3, no? Then how many combinations? 8. 0 to 7. First we need to write like this. Then you can write this input separately, right? If you wish, you can put another column D and this another column E, and we can compare those two and put the output. Otherwise straight away you can compare these two as well. But here the trick is like this. Now once you write this, right, once you write this, all the combinations are written. After written all possible input and output conditions, we need to select separately either this or this condition is true, output will become true. Right, earlier I told you separately you can put, right, the group here, another column here, and you can compare this and write. So in even that time where the ones are coming, you just put ones, and others you no need to compare, we put all 0. Now in this case I haven't put any extra columns. I have written all the combinations for A, B and C, right? Then I am directly writing the output. How? This branch we need to see separately, A and B. We don't care whatever the combination here, right? A and B. See, A and B, right here. A and B. So AND gate, no? Always you know, right? A and B 1, the output is 1. Correct. Another is there, we don't care about this, only we are concentrating here. A and B 1, output should be 1. Then the other branch, A and not C. We have to see where you get A and not C. Where you get A and not C. Here 1. All others 0. Right? Very simple. First you implement the circuit, then you see the Boolean expression, how many input, then all possible combination you write. After that you just consider the 2 branches, because here only you get the final output. No, there may be other stages, right? But only for the final output we have to see this and this. Then without writing any other extra columns, straight away you can place 1, after that all others 0. That is the trick. Now here gas pressure, carbon monoxide level, gas leak detection. Now always 1, if it is correct, 0 not correct. Right? Pressure is okay, mean 1. Carbon monoxide level is okay, mean 1. Gas pressure, gas leak is no gas leak, mean 1. So here the condition, the output X is equal 1. Following condition: gas pressure is correct and carbon monoxide level is too high. X should get 1. Gas pressure is correct, no problem, but if carbon monoxide goes high, X should get 1. That is one condition. The other condition, carbon monoxide level is correct and gas leak is detected. Right? There are 2 conditions, this and this, this and this, either this or this. Now it is very clear, no? How we derive the logic gate. Gas is okay, but not the carbon monoxide. Carbon monoxide is okay, but leakage is not okay. Very simple, right? To and with O. Gas is okay, no problem, but carbon monoxide not okay. So then, because here they are clearly indicating the condition, no, X to become 1. So X to become 1, first we consider this branch. This need to be 1, or else this need to be 1. So this to become 1, gas is okay, we are directly feeding, so this is 1. Carbon monoxide okay mean we can directly feed 1. Gas is also okay, carbon monoxide is okay, we need 1. Now here not. Gas is okay, but carbon monoxide is not okay. Therefore we are putting the not gate. If it is not okay only, we get 1 here, no? So 1 and 1 you get 1 here. See the next condition, carbon monoxide is okay, so therefore we are directly feeding. But leak not okay. Okay mean we can directly feed, but if leak not okay only, we are getting here 1. So leak is not okay, then not, here you get 1. So some kind of circuit is there. If the gas detection is that, they are sending a signal, right? So the gas leakage is there, I mean it's a 0, no? Because here it is clearly given, no? These conditions are given, no? With that only we have to see how to implement, right? So here you need to get 1, and then only you get 1 here. So this how we derive. We just see, right, here O, this side branch, this side branch. Then to fulfill the condition, how to input these signals. Right? If they say gas is okay, carbon monoxide okay, you directly. But when carbon monoxide is not okay, only you should get 1 here. So it is indicated not okay means 0. So some circuit is there, if carbon monoxide is not okay, it will feed 0 to this. Then we need to make it 1 here, no? To make it x is equal 1. Similarly here, this condition carbon monoxide is okay. Whenever the gas leak, it is send the 0 signal. So this need to become 1 to become this one. This is how we need to logically think. If you divide the inputs, then actually there is no worries at all. You can straight away implement the circuit. Now here, after this we know there are 3 inputs, then 8 combinations we are putting here, no? 8 combinations we are putting. Right? After that, here we are concentrating these 2, where we can get G and not C. Where we can get G and not C. G and not C here. Then the output will be 1. G and not C. Another one is there, G and not C. 1. Right? Then we put 1, 1 here. Any other combination G and not C? No. Then C and not L. C and not L. C and not L. Here 1. Here C and not L. After writing all the combinations, we see just both sides. If this condition is okay, output is 1. Or if this condition is okay, output is 1. Then after that you fill all with zeros. Right? Now it is very clear. You need to get familiar with these Boolean expressions and how to draw logic gates and how to construct truth table. So we can see one more example, then everything should be very clear to you. Without any hassles, you should be able to answer all past papers questions. Stay tuned for the next video. Thank you.